Hey everyone, welcome back to Tech Tribus. In this video, we are going to tackle the linked list cycle detection problem, also known as Floyd's Tortoise and Hare algorithm. We'll go through a step-by-step explanation of the problem, various approaches, and a detailed walkthrough of the Java code. Let's get started. So let's take a look at the problem statement now. We are given a linked list and we need to determine if there is a cycle in the linked list. Given head, the head of a linked list, determine if the linked list has a cycle in it. Return true if there is a cycle in the linked list. Otherwise, return false. Now, let's understand what a linked list is. A linked list is a linear data structure where each element is a separate object called a node. Each node contains data and a reference, or link, to the next node in the sequence. Here, you can see a simple linked list with nodes connected linearly. The last node points to null, indicating the end of the list. But what happens if a node points back to a previous node? This creates a cycle in the linked list. For example, if node 4 points back to node 2, we form a loop. Detecting such cycles is crucial as they can cause infinite loops in traversal algorithms. One way to detect a cycle is using a brute force approach with a hash table. We traverse the linked list and store each node's reference in a hash table. If we encounter a node that is already in the hash table, it means there is a cycle. As we iterate through the list, we check if the current node exists in the hash table. If it does, we return true, indicating a cycle. If we reach the end without finding a duplicate, we return false. While this approach works, it requires O(n) space to store the nodes, which isn't efficient. Let's explore a more memory-efficient solution. Enter Floyd's Tortoise and Hare algorithm, an elegant solution that uses constant space. We use two pointers, slow and fast. The slow pointer moves one step at a time, while the fast pointer moves two steps at a time. If there's no cycle, the fast pointer will reach the end of the list. However, if there's a cycle, the fast pointer will eventually meet the slow pointer inside the cycle. This approach ensures we detect cycles in O(n) time and with O(1) space complexity. We have completed Floyd's algorithms. Now let's dive into the code. We have given solution class and the hasCycle method in LeetCode already. We initialize two pointers, slow and fast, both pointing to the head of the linked list. Then we write while loop. In while loop we'll check conditions like slow is not null and fast is not null. Also fast.next is not null. Inside the loop, we move the slow pointer one step forward and the fast pointer two steps forward. If slow and fast meet, it means there's a cycle. To check this we have if condition slow is equal to fast, so we return true. If the loop ends without them meeting, we return false, indicating there's no cycle. Let's run the code now. You can see we are able to run it and all test cases are succeeded. Now we can submit the code. Oh, we have an error. It's because of we missed an operator in while loop. Let's correct it and resubmit. And here we go, it's submitted successfully. Thanks for watching the video. If you like it, please subscribe to channel. See you soon in next video.